Hello and welcome back. This is the final section. We are in descriptive models and accuracy. Define and use appropriate quantities for the purpose of descriptive modeling. Choose a level of accuracy appropriate to the limitations on measurement when reporting quantities. So this is some top of the pyramid stuff to get everything down, especially if you're inventing it yourself. Otherwise, if they give us a formula, we have to use the formula. All right. Descriptive modeling is a way to mathematically describe real-world situations and the factors that cause them. A metric is a rule for assigning a number to some characteristic or attribute. Metrics can be used, think grade point average, to make comparisons. In sports, earned run average is used to compare baseball pitchers, and the quarterback rating compares the performance of football quarterbacks. In banking, a person's debt-to-income ratio can determine whether the person qualifies for a loan. In a good metric, factors that are important to the situation are considered and included in the metric. For example, the quarterback rating includes measures of passing, running, penalties, and other factors that make a quarterback effective. All right. Universities use a metric called academic index to qualify high school athletic recruits. A student athlete with a 3.1 GPA receives a score of 610 in reading, 640 in writing, and 700 in math on the SAT. Use the expression to determine whether the student athlete qualifies at a university that requires an academic index of 186 or greater. All right. So we are now given this. So what we have to do is we got to do some variables here. So receive 610 in reading. So here's our reading score. 640 in writing. There's our writing score. And 700 in math. Let's use orange. And there's our math score. So from the look of this, and this is a big ugly mess of problems, the first thing we're going to do is take the average of their two English scores, reading and writing, and add that to the math score, and then we divide it by 20. All right. And we have our GPA value over here. Oh, we can't forget that. Let's use blue for that. And then we add the GPA value. So they had a 3.1, so our GPA value is 68. So we're going to first average the reading and writing scores. So we add them together, divide by 2, add the math score, divide by 20, times 2, and then add the GPA. That's weird that we're going to divide by 20 and then times 2, because shouldn't you just divide it by 10? I don't know. We'll do the math. All right. So use the table to determine GPA value. We did that. Continue on the next page. All right. So they plug in the values, and they didn't give us the GPA value. Okay. Let's redo this real quick. Pink, yellow, orange. So we go pink. Uh-oh. All right. That's supposed to be... I already messed it up. That's supposed to be yellow. Orange is the math score, and GPA is blue. GPA we looked at on the front side of this told us that it's 68, so let's put that in. So reading, so we take our 610 and 640, we average them together. Divide by 2. It says add 628 and 700, so that got us to here. Divide by 20, so we got to take our 1. See, this 2 right here bothers me because I think we could just divide by 10. Oh well, whoever set this up must know what they're doing. Gives us 66.25. Now we're going to multiply that by 2. 132.5. I'm right. Wow. So this times 2 over here is kind of asinine because this could have just been a 10 under here. This is just added math. We're multiplying by 2 and divided by 20 instead of just dividing by 10. Take a look. If we just had to divide by 10, it involves moving the decimal point. They just added steps here. God, I hate when they add steps to math to make it harder. From here, we're going to take our 1, 3, 2, and 5, add 68, then we get 205. Well, 200.5. So their academic index is 200.5. Because the academic index is greater than 168, the student is qualified. Check. Rachel wants to determine the best rating for a state park for hiking and fishing. Use the metric to calculate a score for each park, round to the nearest 10th. Oh, this is fun. So we take the 100. Ooh, this is a calculator exercise. So we got to take 100 parenthesis 0.2 parenthesis online rating. So the first one is 4.8 divided by 5 n parenthesis. We hit plus 0.4 parenthesis. Next one is miles. So that's 20 divided by 25 plus 0.4 parenthesis 9.8 divided by 10 and n parenthesis. That gives us a 90.4. All right, next up. So we have 100. We're doing our next one. Parenthesis, not 8, parenthesis, 0.2, parenthesis, rating 4.3, divided by 5, plus 0.4, parenthesis, 14, divided by 25, parenthesis, plus 0.4, parenthesis, 8.2, divided by 10, and end parentheses. Enter. 72.4. This is where writing out a function is helpful because you could program this into an Excel sheet and just change the numbers and it'll give you the correct answer every time. All right, next up, Maplewood. So we're going to go 100, parenthesis, 0.2, parenthesis, 4.9 over 5, and parenthesis, plus 0.4, parenthesis, miles, 25 over 25. That's just going to be 1, parenthesis, plus 0.4, and 7.3 over 10, n parenthesis, n parenthesis. Gives us 88.8. And finally, we have the Camden one, 100, parenthesis, 0.2, parenthesis, 4.3 over 5. That's not a 5, that's a 3. N parenthesis, plus 0.4, parenthesis, so that's going to be 15.8. Divided by 25, n parenthesis, plus 0.4, parenthesis, 10.1 divided by 10, n parenthesis, n parenthesis. All right, and that gives us 82.88. So by this metric, that park's the best, Gooseberry. How might someone who enjoys hiking much more than fishing change the metric? Well, what we see is hiking The miles of trail represents 0.4, so this is 40%, this is 20%, and this is 40%. If you like hiking more than fishing, you might change this fishing to 20%. Change fish to 20% and hiking to 60%. We just change these numbers up there because that's the breakdown of 100 we are looking at. What other attributes might high school recruiters think? Do you think universities might consider? Honestly, they do extracurriculars. Immigration status. Some schools accept it. If you're a first generation American to go to college, you can get a grant there. So, immigration status, oh, community service hours. Moving on to example 2. A child's adult height can be predicted using several metrics. Given the height of the mother, father, and their son at 2 years old, use the metric to predict the son's height as an adult. That's interesting. I am taller than both of my parents, so I'm interested to see this. So what do we think? The gray method uses the average height of the parents adjusted by the gender of the child. For a boy, the mother's height is multiplied by 13/12, and for a girl, the father's height is multiplied by 12/13. That's interesting. So, that must be with the X. That must be something to deal with the XY gene. Women have XX, men have an XY. All right. So, we have the mother's height, 65 inches, father's height, 72. We multiply the mother's height by 13/12, gives us 70.42. Average them together. Let's use a calculator. It is just cutting them in half. 71.21. Using the gray method, the boy will be about, let's just say 71 inches tall. Use a source. Find information to create a metric to measure something that is important to you. Explain how your metric includes the factors that you think are important. I like video games. This is a sad metric for video games. All right, so for video game characters. And a metric we could use is number of people who cosplay your character. That's probably a good metric if you made a character or not. If you have a million people trying to cosplay as your character, you might have did something good. If only 4 or 5 people ever pick it up, it might not be that popular, but to those 4 or 5, they love it. The doubling method. The doubling method multiplies the height of a child by 2 at a specific age to predict the child's height as an adult. Height at 24 months is used for boys and at 18 months for girls. So 2 times the height of child. Let's see, he's 2 and he's 35. So that's going to be 70. Using the doubling method, the boy will be about 70 inches tall. All right, that's plus or minus an inch. Not so bad. Ian is applying for a home loan at a national road bank. Uh, no, Ela- uh, Elena. Elena's debt to income ratio must be 0.36 or less to qualify for a loan, and the new saving bank is a mortgage to income ratio must be 0.28 or less. Use the two metrics and information provided to determine whether Elena qualifies for a home loan at each bank round to the nearest. All right. So, national one, her monthly debt, monthly income. So, we have 1165 divided by 3650, and this gives us a 0.319. Then we have mortgage 1068 3650. 1068 divided by 3650 gives us 0.292. 6. You know what was that other one to another decimal point? 91. There we go. We only need to round to 2, so if we look at this one's going to round up to a 32. This one's going to same, so we have 32 and 0.9. So let's see. For National Bank, she must get a 0.36 or less. She qualifies. For the new saving bank, it must be 2.8 or less. Ooh, hers is 2.9, so she does not qualify. Compare the results of the two metrics. How effective are each of the metrics as a measure of whether Elena can afford to buy a house? Well, this one says she totally can. This one says she cannot. Says yes. The other, no. She is close on the other. The way to look at this, if I used both metrics, I see that she qualifies quite a bit here, but she's only slightly off here. I would argue that she should qualify for it because this is close enough and she already qualifies with another metric. All right, this is the last little paragraph we're going to read before we stop for the day. All measurements are approximations. When you measure something, you are limited by the measurement tool that you are using. Accuracy is the nearness of a measurement to the true value of the measure. The accuracy needed for baking cookies, timing the final seconds of a basketball game, and determining the gold medalist of a 100-meter dash are very different. True. Cookies, you can have a lot of fudge factor. The 100-meter dash at the Olympics, they are hyper accurate on that. I mean, they got it down to milliseconds. Whether measurement should be rounded depended on how the measurement will be used and the limitations of the unit which the measurement is taken. True. If you want to look up something interesting, Terrence Howard created a shape that's not supposed to exist, but it's because the materials themselves fall within a tolerance that allows them to go together. Fractions are an exact value. So if you use fractions, consider fractions exact, where everything else is an approximation. Thank you so much. Have a wonderful day.